Hello. Hello. Hello.
Audible.
Now audible. You took too much time.
I am not taking time, sir. If it is connecting fast, I am joining fast. Taking time, then I am also taking time.
That is very simple only. Now nobody can do anything. In
Yes,
case
sir.
of
Very helpless situation, sir. You are joining on time also, you are ending up 5 minutes late.
no problem. Hmm. Why transition metals show catalytic properties? Can you explain?
Sir, once more can you repeat, please, sir?
Why transition metals show catalytic properties?
What property, sir?
Catalytic properties.
So catalytic property. Sir, transition elements will show catalytic property because they have the multiple oxidation states.
Okay, correct. Very good. Because of variable oxidation state, they represent the catalytic properties. What is the reason behind the alloy formation? They frequently form the alloy. Why? Hello?
Sir, because their metallic radii, sir, the metal atom will be distributed randomly, and sir, the metallic radii should be 15% within 15% of each other.
Because they are the similar size. Okay, there is
Within
no much difference in their radii, so they can intermix together to form alloy, right?
yes.
Okay. What is the interstitial compound?
Sir, the interstitial compounds are when hydrogen or oxygen that are attached between the gap between two atoms. It is known as interstitial compound. So that is they are taking up the interstitial space.
Not oxygen, hydrogen,
Yes.
nitrogen, carbon. Hydrogen, nitrogen,
Yes.
carbon.
They're having very high melting point. They're generally very hard, chemically inert and non-reactive property, and they also retain the metallic conductivity.
Okay, correct. Okay. Why the transition metal show the color? What is the reason?
So DD transition charge transfer structure defect.
But main reason you need to give some more points. DD transition can takes place when? When there is the paired electron or unpaired electron?
Sir, unpaired.
Unpaired electron. So since they have unpaired electron, so they are colored. And also they show the DD transition. Due to presence of unpaired electron, they can show the DD transition. So they are the colored full. But in case of KMnO4, what you will give? MnO4. MnO4 minus. Here I am writing MnO4 minus. It is having the +7 oxidation state. And Mn, if you see, Mn is 25. Its configuration is how much? That is the 3d5 4s2. And Mn 7 plus is equal to what? 3d0 4s0. But it is what? It is the colorful. What is the reason you will give?
Sir, charge transfer structural defect.
Since they are having the vacant orbital now, so the ligand, they can take the electron from the ligand, and they will show this is called charge transfer spectra. So due to charge transfer, they show the color. Okay, what about this one? What is the white transition metal? White transition metal metals form complex compound. Form complex compounds. Why transition metal
Sir,
forms
small
complete?
size, sir, small size,
Uh,
high ionic charge and vacant orbital.
very good, very good, very good, very good. Something you study that today I can say you that you study something. Okay, good, good. Now, where we are writing next one. So, oxo oxide, you can write the oxides and oxoanions, oxoanions of metals. Okay. So oxoanions
What
and
is the
oxide.
meaning of the second one, sir? Oxo.
What?
Second
Oxoanions.
one.
ANIONS.
Okay.
Oxoanions. Oxoanions. Okay. So oxides means what? They are oxides if you talk about. So oxide, if you see, they form they form all the type of oxide, all the type of all the types of oxides. That is acidic, comma, basic, and amphoteric. Amphoteric. If you talk about lower oxide, so lower oxide, can you tell me what will be their lower oxide? Any idea about the lower oxide? Acidic, they will be acidic or basic or what?
Sir, they can be acidic.
Oh, why they can be lower oxide? They gives the electron, so they are basic. They are basic. Metal oxide always basic. Okay,
Okay.
metal oxides are basic because they give the hydroxide. Higher oxides. Higher oxide, do you know what do you mean? Lower oxidation state oxide. Oxidation state oxide. Lower oxidation state oxide, they are basic. Higher oxidation state oxide, they are going to be what? They are acidic. They are acidic. And they are talking about in between. They are amphoteric. No, amphoteric, there is no region. They are the amphoteric are also there, right? Like I am writing amphoteric now. Amphoteric. They act both. They act as both what? Acidic and basic. Acidic and basic. They act as both acidic and basic. Okay. So first of all, we are talking about lower oxide. Lower oxides. What are the lower oxide if you are talking about basic? So like CRO. Okay. This is the basic oxide. CRO. Now acidic. If I will talk about the acidic oxide. So acidic, we can write any oxide. Let me see the examples also. I need to see the examples. Okay. Uh, Mn2O7. This is there. Mn2O7. It is acidic. HMnO4. This is also acidic. Okay. Here amphoteric, if you are talking about amphoteric, no, amphoteric, I am writing here amphoteric. So amphoteric is what is there? V2O5 is there. This is the amphoteric. Basic. In the basic, lower oxide, this is the lower oxide already I told you, no, basic. So CRO is basic. V2O4, less basic. This is basic, but less basic. Region is less basic. Another is there V2O3. This is the basic. So as the you will see the oxidation state increasing 4 to the 8 by 2. plus 4. So this is what is less basic. Here is plus 3, 3 to the plus 3. This is basic, plus 2. So lower oxide, you see 2, 3, 4. They are the, what they are talking about. They are the basic. Now, if I will ask you acidic, here you see 7 to the 14 plus 7 is there, acidic. Here is plus 7 is there, acidic. Now, if again you are writing H2Cr2O4, this is how 4 to the 8. 4 to the 8, 8 minus 2, that is plus 6. They all are going to be what? This is the, they are going to be acidic, higher oxidation state oxide. But in between, if you talk about this one, V2O5 plus 5 is between the 4 and 7. So this is what? Amphoteric. So low oxidation state oxide are what they are saying? Basic. Oxides in lower oxidation state are basic. Oxides in intermediate oxidation state are amphoteric. Oxide in higher oxidation state are acidic. If I will classify on the basis of oxidation state, on the basis of oxidation state, what it is this? The first one, low oxidation state. Low oxidation state is going to be what? Basic. Intermediate.
Sir, this is classification of which thing, sir, on the basis of oxidation state? Sir, like
nature of oxide. Nature of oxides. Intermediate oxidation state. This is going to be amphoteric. High oxidation state. This is going to be acidic. Getting?
yes.
Done.
Yes.
Oxoanions. Oxoanions. What are the oxoanions? Oxides with negative charge. Oxides with negative charge are called oxoanions. Like MnO4 minus. Okay, this is the oxoanion. Now Cr2O7 2 minus, oxoanion. Cr2O4, K2Cr2O4 minus 2. So they are the what is oxoanion. Okay, so oxoanions are having the same nature. Low oxidation state, basic. Intermediate, amphoteric. High oxidation state, acidic. Got it?
Yes, sir.
Okay. So these are the answer. Now, compounds of, here we are writing heading, main heading. Compounds of, what we can write is there. You give no. Compounds of transition metal. Compounds of transition metal. This is heading from the NCERT book. Transition metals. So only you need to, there are the millions of compounds of transition metals are there, but you need to study only 2 compounds are there in our syllabus. Only 2, not more than. Okay, what are the main 2 compound? The main 2 compounds of transition metal. Transition metals are, what are there? The 2 main compounds of transition metals are, the first one, What we are tying? Potassium permanganate. Potassium permanganate. This is the KMNO4. Second, potassium dichromate. Potassium dichromate. Generally, their preparation and chemical properties asked. K2Cr2O7. So potassium permanganate. So we are going to study the potassium dichromate. Can I erase this? Study of.
No, sir, writing.
Okay, no problem. Potassium dichromate. First of all, we are studying potassium dichromate. According to book, we are going study of potassium dichromate.
Done, sir. Done.
Okay. So preparation. Okay. Preparation. Important, no? Preparation. They ask the preparation. Sometimes they ask the preparation only. Okay. It is prepared. It is prepared from iron chromite. From iron chromite. CHRO chromite. Iron chromite into 3 step. Into following 3 step. Into following 3 steps. 3 steps. It involves the for 3 steps. Following 3 steps. So what are the 3 steps if you talk about step number 1? Okay. So what is there? Fusion of, see, fusion of iron chromite. Fusion of iron chromite with sodium carbonate. Sodium carbonate in air. In air. To give, what it is going to give? To give sodium dichromate. Sodium dichromate. It is available in the lab also. Sodium dichromate of yellow color. Of yellow color. This is what? Yellow color is there. Sodium dichromate, yellow color. Now see, 4 molecule FeCr2O4. This is what is called iron chromite. CHROMITE. Iron chromite O. Now you are adding the 8 molecule of Na2CO3, sodium carbonate, and 7 molecule of oxygen. So what it is going to give? 8 molecule of Na2Cr4 plus 2 molecule of Fe2O3 plus 8 molecule of CO2. Right, this is there. So this is the step number 1. So firstly, we are converting into sodium chromate. This is what is called sodium chromate. Why it is called sodium chromate? Because only one chromium is there. So this is sodium chromate. Now we are going for the step number 2. Acidification of sodium dichromate. Sodium dichromate to give acidification of sodium dichromate to give sodium chromate. Sodium, not dichromate. This is the sodium chromate, na? Only one Cr is there. Sodium chromate to give sodium dichromate. Sodium dichromate. So we are just acidifying it. So I am taking 2 molecule of Na2Cr4, this one, and adding the 2H plus. So what it is going to give? Na2Cr2O7 plus 2Na plus H2O. This is the two chromium are there. So that is called sodium dichromate. Sodium dichromate. This is called sodium dichromate. Got it?
Yes, sir.
Step 3. Sodium dichromate on reaction with KCl, on reaction with KCl gives potassium dichromate. Potassium dichromate. So what is there? Na2Cr2O7 plus 2 KCl. So it is will going K2Cr2O7 plus 2 NaCl. This is the potassium dichromate. Done.
Sir, you can show from the first step once again.
I'm writing very rough because doing little bit faster.
Okay, sir. So I am writing properly, no, sir. That is done.
No problem.
Sir, that is why I'm taking the extra time for you from you to write. Sir, I think this is the NCRT question, sir. This one.
This is NCRT only now. Full NCRT. Can I erase?
No, no, sir. Writing, still writing. Step 2 writing, sir. Step 1 you can erase.
Okay. We are going to structure a chromatin. Okay. Chromatin, like the sodium chromate is there, na? So what is the structure if you talk about tetrahedral shape? This structure is simple tetrahedral. Tetrahedral shape. So how
Sir,
can
step
you
2
draw?
not done. Step 2 not done, sir. Step 2, sir.
This is the step 2 now.
Done, sir. Step 2 done. Step 3.
This is the structure of the chromate ion. Done.
Yes, sir.
Now, structure of dichromate ion. Dichromate ion. K means Cr2O7 2 minus. Dichromate means chromium should be 2. Cr2O7 2 minus. So now it is there. This is the common oxygen. Here is the chromium. One oxygen is common and which is being shared with the two chromium. So one oxygen is there. Here chromium, chromium. So they are also going to be tetrahedral arrangement. O, O, O. Similarly, this is oxygen, oxygen. So this is the tetrahedral only. This structure is also tetrahedral. But what is there? Each chromium atom is linked with the common oxygen. This oxygen is called common oxygen. Common oxygen. If you see the bond angle, this bond angle, this one, this bond angle is 126 degree. If you are writing the bond length, oxygen to chromium, 179 picometer. And oxygen chromium is 163 picometer. This is not required. Bond and all these all not required. Just they asked to draw the structure.
The structure of chromate ion, can you show me once more, sir? Done, sir.
So it is called two tetrahedral structure joined with same oxygen. Joined with same oxygen. You can make it if you want to see like that. What you are going to find? They are going to tetrahedral. Yes or no? Is it? Are you looking that they are tetrahedral?
Yes, sir.
Hmm.
So writing, sir.
Okay, no problem.
CRO.
Physical properties. What is the physical properties if I will look? It is orange, crystalline, solid. chemical properties. Chemical properties. Case first, chemical properties. Reaction with base. Reaction with base. It gives chromate ion. Chromate ion of yellow color. It gives chromate ion of yellow color. So what is there? Cr2O7 2 minus. It is treating with the 2H minus. So 2Cr4 2 minus plus H2O. So this is what is going to be chromate. So if you are treating with the base, it is giving chromate ion. Reaction with acid. Reaction with acids. Reaction with acid, it does not give. It does not react with acid because it is already acidic in nature. Note. On acidification, chromate ion converts into on acidification, chromate ion converts into dichromate ion. So what we can write here, 2Cr4 2 minus plus 2H plus. What is there? Cr2O7 2 minus plus H2. Done.
Writing, sir.
Done.
Last line writing, sir. Done, sir.
Okay. Now, oxidizing properties. Oxidizing properties. It is a strong oxidizing agent. Strong oxidizing agent. It is a strong oxidizing agent. So how can you say as it oxidizes the following ion? Oxidizes the following. So if I will write Cr2O7, 2 minus is there. So how it is going to oxidize? Right? I minus 2 I2. This is the first one. S2 minus 2S. H2S2S. Third, SN2 plus 2 SN4 plus. Fe2 plus 2, Fe3 plus. Getting?
Yes, sir. Sir, I will write, sir.
Itself reduce into, when it oxidized, so it will self get reduced, na? Itself reduced into Cr3 plus.
Sir, can you kindly keep this one, sir? I'm writing.
Hmm.
Done, sir. Done.
Okay. So now I'm just explaining the balance equation, because in the exam you need to write the balance equation. So first one you see, that is Cr2O7, 2 minus is there, reacting with I minus. So it is going to be I2. Plus it is converting into Cr3 plus. Getting? So all the method you already know now. Here oxidation state is +6, here oxidation state is +3, -1, 0. So how can you balance here? See this one. So this is gain of how many electron? Gain of 3 electron per atom. Per atom 3 electron. So how many atom are there? 2 atom. So multiply by 2. So 6 electron per 2 atom. Per 2 atom. So 2 atom are there. So how many? 2 electron. So here again I multiplied by 2. Now see this one, I. So here is what is loss of 1 electron. I minus to 0, loss of 1 electron per atom. But here how many atom are there? 2. So multiply by 2. So 2 electron per 2 atom. Per 2 atom. Now what we need to do? We need to equal the that is what charges. Here 6 electron is there, and here how many electron are there? That is 2 electron is there. And this one, see here I2 is 2. So here already I multiply by 2. Why I multiplied by this is, why I multiplied by 2? The reason behind is why I multiplied by 2. What can be the reason behind this? Because per 2 atom, 2 electron, per atom 1 electron. So now here this you can see 2 electron, and here you can see 6 electron. How can you make it equal? So you can multiply it by these 3. So it will be equal. So I am writing Cr2O7 2 minus 3 to the 6 I minus 3 I2 plus 2 Cr3 plus 7 oxygen is there, here no oxygen, so that is 7 H2O. Here hydrogen is 14, here is 14 H plus. You can check the answer. Now it is balanced. Check. This is oxidation number method only. Cr, this side Cr, O, O, I, H, H. Then what is there? Charge and charge. Chromium how many? 2. Chromium how many? 2. Oxygen 7. Oxygen 7. Iron 6. Iron 6. hydrogen 14, hydrogen 14, charge 2 minus 6 minus 14 plus, so 8 minus plus 6 plus 6, so it is balance. Will you be able to do this one?
Yes, sir.
Hmm.
Sir, but you can put it a bit like upwards. You can scroll.
What upward? This is only the equation. This is the equation which you need to write in the board exam. But you need to, before that you need to learn how to balance in
Sir,
a
what will
fraction
be
of
the
the,
question for this one, sir? What will be the question for this one?
they will give the reactant, this portion they will give, this portion they will say the write the product.
Done, sir.
Okay, one more reaction I am doing. This one, suppose this one I am doing SN2 plus and SN4 plus, Cr2O7 2 minus SN2 plus, so Cr3 plus SN4 plus. So first of all you see the change, plus 6 plus 3 plus 2 plus 4, this is there. So now 6 to 3 plus 6 to 3, okay, gain of how many electron? Gain of 3 electron per atom. Now we are multiplying by 2, so 6 electron per 2 atom, per 2 atom, per 2 atom how many are there? 6 electron. So I this multiply by 2, because here 2, so here per 2 atom we calculated. Per atom 2 to 4, loss of how many electron? Loss of 2 electron per atom, per atom. But here 6 is there, here 2 is there, so we have to multiply by 3. So we will get that is 6 electron loss and 6 electron gain. So after multiplying you write down this one, Cr2O7 2 minus plus 3 Sn2 plus 2 Cr 3 plus what will be there? 3 Sn4 plus. How many oxygen? 7. So here will be 7H2O. How many hydrogen? 14. So here will be 14H plus. Now this is balance equation. You can check. It is not taking even 30 seconds. You can check chromium, chromium, oxygen, oxygen, Sn, Sn, hydrogen, hydrogen, charge, charge. Chromium how many? 2. Chromium 2. Oxygen 7. Sn how many are there? 6 plus. 6. Oh, sorry. Sn3. Here is Sn is 3. 14. 14. Charge. 2 minus 3 2 just 6. 6. And 14. That is 20. That is it is plus 18. 2 3 just 6. 3 4 just 2. Plus 18. So now everything are balanced. You can check.
Done, sir.
Okay. Next, what we have to do? Third reaction also I am balancing. Third one, what is third one? Last one you can see Fe2 plus Fe3 plus. Remaining you do by yourself. Okay. Cr2O7 2 minus. They are talking about Fe2 plus It is converting into Cr3 plus Fe3 plus. What is there? So here is what is there, plus 6 plus 3 plus 2 plus 3. So 6 to 3, gain of 3 electron per atom, multiply by 2, 6 electron per atom. Here is loss of how many? Loss of 1 electron per atom. But here 6 is there, here 1 is there. So we are multiplying by 6. So it will become 6 electron. So if you are this is 6, so you have to multiply. Cr2O7 2 minus 6 Fe2 plus 2 Cr3 plus, since here chromium is 2, so here is also 2, and 6 Fe3 plus. If you see oxygen 7, so 7H2O. Hydrogen 14, so it is going to be 14H plus. This is valence equation. You can check it. Chromium, oxygen, hydrogen, iron, charge. Chromium, oxygen, hydrogen, iron, charge. Chromium is how much? 2. 2. Oxygen is how much? 7. 7. Hydrogen is 14. 14. Iron is how much? 6. Charge, how many are there? 2 minus 6 to the 12. 12. 12 4 16. 36. So this is the plus 34. How much? 2 3 is 6 plus 6 plus 18. 24 is coming. 14 12 22 2 24 24. Wait, these charges are little bit tricky. So minus 2 plus 12 plus 14. So that is plus 24. So these are also balanced. Everything is balanced. Done?
Sir, writing the charges.
Mm-hmm.
Done, sir.
Now, study of potassium permanganate. Study of potassium permanganate. Study of potassium permanganate. This we are going to study. Study of potassium permanganate. That is in bracket KMnO4. KMnO4. It is also a strong oxidizing agent. Oxidizing agent. Okay. Now, what we are going to study, we are going to study the preparation. Okay. We are going to study the preparation. So it involves two steps. Compared to that one, it involves two. It involves following two steps. Following two steps. What is there? Step one. Step one. In the presence of an oxidizing agent, what they are saying? pyrolusite ore. Pyrolusite ore is fused with what? KOH in presence of KNO3 in bracket oxidizing agent. This is in bracket oxidizing agent. KNO3 is oxidizing agent to give dark green color, dark green color, dark green color compound of K2MnO4. K2MnO4. So here you see 2MnO2, 4KOH plus O2. So this is 2K2MnO4 plus 2H2O. So this is called potassium magnet. Potassium magnet. Now step number 2. In neutral, either you take neutral or acidic medium, acidic medium, K2MnO4, K2MnO4 disproportionates to give permagnet. So whether it is neutral medium or acidic medium. So 3MnO4 2 minus. If you ionize this one, so it will give MnO4 2 minus. We are adding the 4H plus. We are taking the 2MnO4. Potassium we are not taking. So what it is going to give? It is very simple, not very difficult. 2MnO4 minus plus it will give MnO2 plus 2H2O. This is permanganate ion. Permanganate ion. If you add the potassium, negative charge will be out. It will be potassium permanganate.
Sir, now show me, I will write.
From here, where? Preparation. Write down. Have you taken the dinner?
Yes. Sir, you can show that one, sir. Pyrolusite ore is fused with the
KOH in presence of KNO3 oxidizing agent to give dark green colored compound K2MnO4.
step 2. I'm writing.
Okay. One more method is there, commercial preparation. Okay, that one also we have to look. Okay, because they sometimes they ask these all the methods. How you will remember that is the by practice only. When you solve the previous year, then this all the problem will be solved. Commercial preparation of KMNO4. Okay, step 1. Step 1, it is step 1 is same. Step 1 is same. Okay, step 1 is same. Oh God. So step 1 is same means what we are taking MnO2, right? What is there? MnO2. Then what we are using? Fused with KOH. We are fusing the fused with KOH. Okay, this is the first condition. Secondary condition, with oxidizing agent. What we are using? With oxidizing agent. With oxidizing agent KNO3. Or you can take air also. So it will give MnO4 2 minus. This step already you wrote. MnO4. If you ionize this one, it will give the MnO4 2 minus. Now, step 2. Step 2. The electrolytic oxidation of magnet ion to obtain permanganate ion. To obtain permanganate ion. So how can you do?
Can
This
you
is
show
there.
me the step 2 of the previous one? Previous one, step 2, sir.
Wrote na. You said how much time you are taking. I will share
Sir,
you
the
the slide. I
sir,
will
the
share you
reaction.
the. I will share you the slides.
Okay, okay, sir. Okay.
So MnO4 2 minus electrolytic oxidation. We are doing electrolytic oxidation in alkaline solution. So what is MnO4 minus permanganate ion. . This is going to be permanent.
Sir, can we do the next topic for tomorrow, sir? It's actually getting very late.
Tomorrow morning I cannot take. Morning I'm not available nowadays. Evening I will take. Okay, 10 o'clock or 10:30 you call me, right?
Okay.
Okay.